Apple will be releasing a new MacBook in late 2020. This new MacBook isn't just your average incremental upgrade though. This thing is going to have a new custom designed CPU made by Apple. This will be the fourth CPU architecture that Apple has used for its computers so far. First was Motorola's 68K, then IBM's PowerPC, followed by Intel's x86, which is what's currently in use, and now Apple's own in-house chip. It's not a fully custom CPU solution, however. This new CPU that Apple is working on will be using the ARM instruction set. They are the same type of CPUs that power smartphones and tablets, but make no mistake, these new CPUs from Apple will have desktop class performance. Again, these new MacBooks will be MacBooks. They will not be iPads with built-in keyboards. It's important to know that Apple won't be licensing a CPU designed from ARM, but rather they will be licensing the ARM instruction set itself and building a new CPU from the ground up, maximizing performance and minimizing power consumption. Speaking of power consumption, expect 24 plus hours of usable battery life. That's right, a full 24 hours of actually using your computer. This isn't standby time or idle time. It's not running a word processor for 24 hours, but like 24 hours of watching YouTube for real. There's usually some sort of trade-off between battery life and performance, but you will not find that here. Switching to the new CPU will give the late 2020 MacBooks massive battery life gains while also seeing a jump in performance. This was shown in the Lenovo 5G, where the ARM-based Snapdragon 8CX outperformed the much more expensive and much more power-hungry Intel Core i5 8000 series. Because the battery life is going to be so good on these new computers, there will be a host of other changes that will now suddenly make a lot more sense. Things like instant on and always on technologies. Instant on refers to the fact that when you push the power button, your computer turns on instantly. Well, this is actually just an illusion though. What's really happening here is that the computer is so power efficient you never really have to turn it off. Pressing the power button will basically just toggle the screen like on your smartphone. Always on refers to a computer's internet connection. Because the CPUs in these new machines will be so power efficient, it will be possible to have a cellular modem that is always on and always connected to the internet. Try doing that with an Intel chip and you will find that your battery will be drained in no time. Also, a battery's overall lifespan is a function of how often it's completely charged and completely drained. This means that a battery that lasts longer on a charge also lasts longer before needing to be replaced. And remember, these new CPUs are going to use a lot less power than their Intel x86 counterparts. So that means they will produce a lot less heat. It's safe to expect these new MacBooks to be fanless systems with tiny slivers of heat sinks. This is going to allow for much thinner and much quieter designs. Okay, so Apple's going to release a new MacBook in late 2020, right?
Yep.
What does that mean? Is it going to be a new operating system or what?
I'm sure it's going to be a new operating system because the CPU architecture is totally new.
So what's new about the architecture?
Well, it's based on the ARM instruction set. So, you know how smartphones and tablets have like totally different processors because you can't fit those big, heavy, power-hungry chips in phones? Well, the ARM architecture is what they use. So they're actually making full-size laptops and probably desktops later using this architecture.
What is the difference between this new chip that's coming out and the ones we use now?
Well, the new chip is actually in wide use. It's actually the most common type of CPU on the planet. It's the unusual part is that it's in a full desktop class computer. It's a laptop, but it's in a normal PC. So the difference is that the old chips that we put in regular computers are x86 architecture based chips. So it's a CISC instruction set, which is a complex instruction set. That's what the C is for. ARM chips, like the ones in phones, tablets, millions of tiny little devices like microwaves and fridges and all kinds of stuff. Those are RISC chips, which is a reduced instruction set.
Okay, what makes a chip a RISC chip then?
Okay, so to explain this in simple terms, they call one complex and one simple, basically, which is the reduced. CISC chips are complex because they include a lot of instructions. They're made for compatibility. So anything made on like the very first CPU, like a program to run on the very first CPU, which is the Intel 4004 released in the 70s, will literally run perfectly with no modification required whatsoever on a brand new Core i7. I mean, I think that's pretty amazing that we've built in legacy support on a software level literally infinitely, and it's pretty awesome. However, there are some downfalls. You have to design in a lot of hardware and a lot of software support for things that most people in most businesses even will never use. I mean, there's so many more advanced instructions that come with newer chips like SSE, MMX, and all kinds of other things that far outdo the old stuff that the 4004 and then the later chips like Intel 386 and 486 can do. But it's done in the name of compatibility. If that wasn't done, the computer industry wouldn't be what it is today. I mean, it's really great that they did that, and it's really amazing that they were able to do that. But RISC turns that all on its head. RISCs, the people that designed the RISC architecture type chips saw an opportunity in the fact that, well, most operations, most programs don't need legacy support. You can build new modern stuff based on CPUs that can only do new modern stuff, and you will have no problems whatsoever. So the two paradigms between RISC and CISC is one is robust and compatible, that's CISC, and the other is efficient and lightweight. So they're easier to design, they're cheaper to manufacture, and they're typically higher performance, and the trade-off is you get better performance per watt versus compatibility.
So you're saying a laptop made with one of these ARM chips would be superior?
Yeah, superior in the fact that it'll run whatever program you need it to run using less power and using less chip. The problem has been up until now that, like I said, you cut out a lot of compatibility because you just don't have those complex instructions. So you have to write all new software. The thing is, if you do write all new software, it will be a great experience. It'll run on these better new modern chips. But there's a huge installed base of a lot of software, and people would not buy these things if they had those limitations. I mean, you can sell it with all the benefits from using a new chip, a RISC chip, but no one's going to buy it if they can't run the software that they've already paid for and that they're already used to using. But the big difference now is that CPU architecture and CPU manufacturing has become so advanced at this time in the last year or so that these reduced instruction set chips can actually pretend to be complex instruction set chips. So this is not the first ARM laptop. It's not even the first ARM laptop to run a desktop operating system, although that segment is very new. The first laptop to run an ARM processor like this is in any appreciable amount of performance that can actually be usable. We find that on the Lenovo 5G. It was just recently released. It runs Windows. It's got a Snapdragon processor, which is the same brand, it's Qualcomm, the same chips that are used in phones, same family of chips. But this chip is dedicated for this type of platform. It's made for laptops. It's not just a phone chip. And it is fantastic. It can outperform an Intel Core i5 8 series chips in a lot of benchmarks, and that alone is impressive. The great thing is it can pretend to be one of these older style CISC chips better than the CISC chip is able to run its own program. And that was in a Lenovo that runs Windows. So that's a really loose software ecosystem where no one organization has control over everything. As we all know with Apple, they run a tight ship. So Apple's implementation of the compatibility layer is going to be much better just on the software level. If you're running Apple's emulation software on the platform that I just told you about, it would run way better than that one does, and it already does a great job. But this is going to be on a new chip made from Apple. And Apple makes some of the best CPUs on the planet. If you look at the iPhones, they're much lower clock speeds and much lower core counts than Android counterparts, yet they are much, much faster per clock cycle. That means Apple has an advantage in tight software control and in hardware performance. These chips are going to be fast.
Well, if these ARM chips, as you said, have been used in phones and tablets for years now, why is Apple doing it now?
Well, Apple waits. Apple likes to see a technology mature before they use it. Look at their adoption of AMOLED. It took them years to get on the AMOLED bandwagon, and now they're on it. And this is often seen as Apple lagging behind the rest of the industry in innovation, but what they're really doing is they're waiting for the technology to mature to a point to where it's acceptable to put their name on it. And at this point, the ARM architecture is at that level.
Interesting. So, I guess my next question is, are they changing their laptops?
Well, they're changing the CPU design. This is not an experiment. This is something that they've been working on for a long time. They've been maintaining an ARM-compatible version of OS 6 for quite some time. Apple's really good about not having leaks, so not a lot of people have heard about that. No one's seen it, but the software is much more mature than you would expect, so that will change. Now, Apple keeps a consistent product. You can expect this MacBook to look like a MacBook. If it looks any different, it's because they've added some sort of extra feature, which they probably won't do. For example, like it's going to have the scissor keyboard, but I don't think it'll have many different changes on the outside. In fact, most people aren't even going to know or care that it has a new CPU architecture. So this thing's going to look like a MacBook. Now, it's probably going to be a little bit thinner, and it's probably going to be a little bit quieter because these CPUs run cooler and need less cooling equipment.
Is this going to be iOS or macOS?
This is going to be an actual MacBook. Apple's not going to put the MacBook name on something and put iOS on it. So this is going to be a MacBook and a MacBook Pro. It's going to be just like any other MacBook. So it'll be running OS 10.
OS 10, okay. So, will that affect software developers for Apple products?
You know, technically, yeah, that's a big mess. I mean, it's a totally new architecture, but software's come a long way and compilers are pretty advanced. Chances are there's probably going to be some sort of dual compatible cross compiler released if it isn't already out there in the wild somewhere where you can basically write once, run everywhere. So yeah, they are two completely different CPU architectures, and one program written for one is not going to directly run for the other. Now, remember, there's going to be a compatibility layer, so developers don't necessarily have to change anything, but for the best performance, they do want to write natively for ARM, okay? So there's three options. One, run your program in compatibility mode. Two, make a new program with their new development kit that they're probably going to release that will allow you to make a dual mode, okay? Or, and this is the best case scenario, make it for ARM.
Okay, with the technical stuff out of the way, I think most people at the end of the day really want to know is how much is this thing going to cost? Because, Apple just put out their newest phone, the iPhone 10, $1,000, the most expensive phone yet. Do you think the same thing will happen with this?
It's probably going to cost an arm and a leg. Well, okay, so these ARM CPUs are much cheaper to manufacture and much cheaper to run, and they're much smaller, so you need less support infrastructure in the computer, less fans, less heatsink, etc. However, it's a totally new architecture, and they've had to develop it in parallel with maintaining their current installed architecture. So the initial purchases of this hardware, you can expect to pay back the research and development. So they're going to be more expensive than the traditional computers at rollout, but then as that R&D gets paid for, the costs are going to plummet rapidly.
You're saying that this ARM chip is going to change the laptop, I guess, basically.
Well, it's going to change the MacBook. And what happens to Apple happens to everybody. Look at the GUI. Look at the mouse. Look at the full screen capacitive touchscreen. Look at MP3s. They are the market leaders. Look at the notch. Look at the screen notch on cell phones. Everything. Everybody copies Apple. So yes, absolutely. Now, don't get me wrong. Apple was not the first ARM laptop, and it was not the first full desktop class operating system ARM laptop either, just like it wasn't the first smartphone. Remember BlackBerry? But they're going to make the first really good implementation of it. It's going to be widely accepted because of the Apple brand. And it's just a matter of time until the competitors copy Apple. And as we know, when people copy Apple, they typically make a better product at a lower price.
Excellent. Well, thanks, Joe, for talking to me.
All right, you're welcome.
All right, I'll see
Thanks
you.
for having me.
No problem. I'll see you next time.
All right, you have a nice day.
All right, that was Joseph Everett on video call. He is a journalist and tech expert writing for Tech&Geek.com. This podcast is brought to you by One Chair Room Productions, a media company at OneChairRoom.com. Thanks for listening, and don't forget to subscribe and leave a review. This has been Tech Daily. I am Matthew, TTFN.